Okay, welcome back. So in our last video we talked about how to graph linear inequalities. Now today we're going to do systems of linear inequalities. So just like systems of linear equations, with inequalities, same thing. We're going to graph two lines, and instead of finding out where they meet, we're going to find where their graphs overlap. So our objectives are you will be able to graph and solve systems of linear equations in two variables. And our objectives, language objectives, are you'll be able to define system of linear inequalities and a solution of a system of linear inequalities. I think it's important to start off with just doing regular inequality on a number line. So if we were to graph x is greater than 2 and x is less than 5, let's see what that would look like. Well, for the x is less or greater than 2, we would go to 2, we would do an open circle because it has to be greater than 2, not equal to, and then we would go to the right. For x is less than 5, we would do an open circle and we would go left for less than, and then they would hit. So our answer would be anywhere in between these two open circles. So our answer might be 2.1, it might be 2.5, it might be 4, it might be 3, it might be 3.5. So anything in here would be an answer. So next, they're going to give us a point, -1, -3. We want to know if that ordered pair would make both statements true. So it has to make both statements true. So, like we did before, we're going to substitute in the -1 and put it right here. Alright, so I decided to move my work over here. So I took this equation, I rewrote it, and instead of y, I substituted in -3 because that's really y. So I put that right here. Then I took my -1, which is x, and I put it right here. So I did the same on the bottom equation also, and I tried to color code it for you to show where I put stuff. So let's do -3 multiplied to -1 gives us a positive 3. And now I need to add the 1. So 3 plus 1 is 4. Now I'm going to check my inequality. And the inequality says that -3 is less than or equal to 4. Well, is -3 less than 4? Well, I would say yes, true. So the first statement is true. Now let's check the second one. 2 multiplied to -1 is -2. And what's -2 plus 2? That's 0. Now let's go back to this and bring it down. Is 0 greater than -3? Or another way to say it is -3 less than 0? And I would say yes. Yes, it is. So this is also true. Because they're both true, then we say yes. This point right here will be in the solution set for when we graph these. And you'll see what I mean more by that in the next slides. Okay, just like in our last video, you had to graph a linear inequality. So that's what we're going to do, except we're going to do it twice. So let's graph this first one. Y is less than or equal to 3. Well, I'm going to use red. Now, remember, if y equals 3, that means I put a dot at 3, I put a dot at 3, I put a dot at 3. Now, it does say less than or equal to, so because it's less than or equal to, I'm going to do a solid line, okay, solid line, and it is, like I said, saying less than, so remember how to do that? I put my pencil on the line, and less than means go below the line that I drew, below. So I'm going to shade in all of this. This is all shaded in. Now I need to graph this line. Well, it's set up in slope-intercept form, so I'm going to start at 5. And I'm going to apply the slope, -1. So down 1, right 1. So I'm going to go from my 5. I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And I look up before I join this, and I see that it is greater than, not equal to. So it is a dotted line. It's going to be a dotted line. And because it said greater than, that means I go right here, and greater than means get bigger, so I go above my line. So watch when I shade. Right now I'm not touching the red, but as soon as I touch the red, this will be my solution set. So my solution is where red and blue meet. That equals solution. That equals my solution. So there's my answer. Any number, any point in this little area will count. If it's on the red line, it'll work. If it's on the blue line, it will not work because it's dotted. Okay? In order to be on the line and count, it has to be solid, not dotted. So anything in here or on the red line. Okay, here's another one to practice. So if you want, you can pause and try this yourself. Let's get this in slope-intercept form. So I'm going to rewrite that top equation. Okay, so look, my blue equation will be the second one, and my red equation will be the top one, and I rewrote it. I moved the minus 3x to the other side, and I divided everything by 2. This is what I ended up with. That's a plus 1. So I already started to graph my red line. I started at 1, and I went up 3 over 2, up 3 over 2. And remember, solid line, because it could be equal to, so I'm going to have to make this a solid line, and I'll do that right now. And once again, where do I do my shading? I put my pencil right here, and I say y is greater than or equal to. So greater than means go above the line. So I'm going to shade this area. Next, I'm going to graph my blue line. I'll start at 3 and go up 4 over 1. So I did graph my blue line, and it says less than, not equal to. So notice dotted and less than. I'm going to go right here and go below the blue line, below. And when I do that, if you look close, there's my solution set. Now you can shade in all of this, that's fine. But remember, the answer I'm going to circle in black. The answer is right there. Okay, the answer is where blue and red meet. So remember, I always say that's my solution. You'll be asked on tests or quizzes to name a point in there. So I might say 2, 1, 2, 3, 4. I could say 4 because it's solid. 4, 5 to be safe. So I could say 2, 5 is in my solution set. Remember, you cannot include anything on the dotted line. Dotted line is out of bounds. Here we go again. Let's graph another one. Let's have the top one be red again, and the bottom one be blue again. How about you hit pause on this one and see what happens? So how about hit pause right now. You try and graph it, see how you do. I graphed the red line. Let's see how I did. I started at -4. I went down 2 over 1. I made a solid line because it could be equal to, and it said less than, so I went below the red line. I went below the line. Now, y is greater than -2x plus 5. So now let's graph the blue line. Here's my blue line. Notice it's dotted because it is not equal to, and it says greater than. So I go to the dot, and greater than means go above the line. So I go above the line. Well, what do we notice? What do you notice about the red and the blue shaded areas? They don't touch. And maybe you notice that the slopes were the same. That kind of had something to do with it. But they don't touch. So this is going to be no solution. And that happens sometimes. Sometimes there's no way, there's no possible numbers you can put in both of these to make them true. It'll be impossible. So this is no solution because they never touch. Let's graph this one and see what happens. So the top line again will be red, and then this one will be blue. Feel free to hit pause and try it yourself. I'm going to do this one and speed it up a little bit because I think we know how to graph by now. So here I go. There's my red line, dotted because it's greater than, and greater than means shade above the line. So I did that. I shaded above. Now I'm going to graph this line. Okay, so here I have my blue line. I started at 6 and I went 3 up, 1 over, and I continued the pattern. I did make it dotted. If you look close, the blue line is dotted because it's less than, not equal to. And I'm going to put my pencil on the y-intercept and look at this, and it says less than, so remember, I do go below the line. Now, if I shade below the line and I just stop where I run out of red, look at my solution is right in between those parallel lines. So not all parallel lines are no solution. On inequalities, you really have to graph it to see if they touch or don't touch, and these do touch. So red and blue equals my solution, and my solution is right in the middle between the two lines. Again, a point in the middle might be 0, 0. 0, 0 would be right here, and it would be in the zone. Do not pick anything on the dotted lines. Those are out of bounds. They will not count. Dotted lines are out of bounds. 0, 0. Origin, the owl. Whoo, whoo, whoo. Ooh, he's winking. Something like that. Okay. Alright, you've spent a lot of time on this video learning how to graph linear inequalities and systems of linear inequalities. Now they're going to give you the graph. You have to write the linear inequalities. We'll have a red one and we'll have a blue one. So let's start with our red one and then we'll get to our blue one. Well, first thing I know is it's going to be y. The next thing I can tell is if I look at this red line, I see that it touches at -2. So I'm just going to write a -2 because I know that that's the y-intercept. Now I'm going to look for the slope. Up 1, right 1. Up 1, right 1. Up 1, right 1. So my slope is 1x. The part I'm missing is the inequality. Is it going to be a greater than sign? Is it going to be a less than sign? Maybe it'll be greater than or equal to. Maybe it'll be less than or equal to. I don't know, so I better look. I see that it's dotted, so that means it will be one of these, and it's shaded above the line. The red is above the line, so that means greater than. It's getting bigger going up. So this is y is greater than 1x minus 2. That's the equation for the red line. Notice it's dotted, so I did not say equal to. Now let's do the blue line. The blue line touches at 3. So again, I'll do a y, and this time I'll say plus 3, because the y-intercept is positive 3. It looks like I have a negative slope here. I'm going to go down 1, and then go 1, 2, 3. So it looks like my slope is -1/3. I can double check that. 1, 2, 3, down 1, 1, 2, 3. Yep. So I'll write -1/3 x. The only thing I'm missing is my inequality. So I go to the blue line. Did I shade above or below? And if I look, I shaded below the blue line. So that means less than. But it is solid. So it's going to be this one. Less than or equal to, because it is solid. So less than or equal to, solid line shading below. There are a lot of practice problems. Sorry about that. You can do them though. So here's the first practice problem. Here's the second practice problem in case you need to hit pause. Here's the third practice problem. Make sure you shade and indicate where your solution area is by a little key. So if it's where the red meets the blue, let me know that. Another practice problem. A last practice problem. Okay, so bring any questions you have to class next time we meet, and take care. Good night.